All right, all right. So this is where part one and part two are going to have a baby. Um, I know it's going to feel weird, but it'll be okay. So basically, what we're looking at here is daily amount spent by consumers, normally distributed with a mean of $74 and a standard deviation of 1730. And what we want to find is we want to find the probability here for A that a consumer spends less than $90 per day. So the amount they spend is less than $90. Why is the pen writing so much worse this time? I don't know. We'll figure it out. Anyway, so the point is to do this, what you would have to do is you're like, well, I can't look 90 up on the table. I can only look up z-score. So I need to change this into a z-score. So I got to figure out the z-score first. So z is going to be my value of interest, that $90 minus the $74 divided by the standard deviation, which is 17.30. Dollars divided by dollars. So dollars minus dollars is still dollars. Divided by dollars gets rid of dollars. So now this has no units, which these scores don't. So this is 0.92. It's actually 0.92485 and a bunch of other numbers. I just only wrote down so many of them. But that's one downside. So actually, let me write more decimal places for this just to remind yourself, because this is going to be more accurate. That, you know, you look at this and you're like, okay, so this is going to be the same as, I should have written these better, the probability that z is less than 0.92 on our table. So what we do now is we go over to our table, which I still have open right here, and scroll down to 0.92. Where is it? 0.9 and then 0, 1, 2, and we come up with, oop, wrong one, 0.8, come on, 0.8212. And I want to write this down, and I'm going to write something next to it. One from table, because I'm going to do this a couple different ways. From table. That looks like nonsense. Sorry, I can't live with that. That one's just so bad. TABLE. If you sing it, it makes it easier to make the stupid pen right. Okay. And that's all grand and everything, but we had to round it to get this. I mean, the table's only good to two decimal places. So you should look at this and be like, there's got to be a better way to handle this. And there totally is. Let's go to Minitab. Hidden behind door number 1 is Ministab. Okay, this is Minitab 18. Fun fact, not Minitab Express. So I'm going to do a probability calculation using Minitab 18 and the standard normal distribution. So I'm going to use the z-score, the standard normal score. And then I'm going to show you how to do this without using the z-score at all, which is how I prefer to do this. So to do I think the easiest way to do this is using graph, probability distribution plot, over to view probability. We always use view probability. You will never use any of these other three, just so you know. We'll hit OK. And it automatically pops up with normal, mean 0, standard deviation 1. It's the standard normal distribution. Oh my gosh. It appears that this automatically assumes you're going to be doing the z-score thing because it is literally the most common thing that gets used for. Just so you know. So let's go to shaded area. Because basically this is just asking you, hey, what are you doing this on? This guy, standard normal. Now I got to tell it what I want. So what area do I want shaded? So just like a calculator, it is going to output what you don't know. What you input is what you do know. So what do I know? Do I know probability? No, I know z-score, which we know is x value. It's the same thing. It just calls it x. It should be whatever variable you're interested in. All right, so as we look at this, I want stuff smaller than $90, or z-score is smaller than 0.92. So if you're thinking about the number line, this is the stuff that lies to the left of 0.92. So I don't want right tail, I want left tail. And then, because I'm this kind of person, I'm only going to put in 0.92 for this first one, and then hit OK, because that's the same thing I did with the table. Ta-da! They're about the same. Okay, this cut off one decimal place that the other one didn't. And that's all well and good, but that's not really the value. My value is actually 0.92485, which is much, it actually goes further than this. It's much farther than just 0.92. So not only can I get the value that we got from the table, but I actually can get something more accurate. So there's this little edit last dialog button that's kind of fun on Minitab 18, that if you click on it will bring up the last thing you did. So in particular, I did a left tail, 0.92. Let's put in the rest of the places. 4, 8, and then 5. And hit OK. Aha! So, more accurately, it is 0.8225. And that's fun. But at the same time, I can do even better than that. It turns out this is actually harder than this needs to be. If you want to do this using Minitab and not by hand, you can take it one step further and not do the z-score at all. So really, where this area comes from is doing the z-score. The fact that you can take any normal distribution and turn it to a z-score. Minitab will do it in all one step though. So it essentially will remove this step and hide it behind the scenes and just output your probability for you. So I'm going to click the last dialog button. So remember, we were a standard normal distribution, but our mean was 74. And our standard deviation was 17.30. Alrighty. Oh, I hit the wrong button. Hold on. Let's pretend that didn't happen. And then what I'm really looking for is stuff less than $90. So notice everything I'm doing here is no longer the z-score stuff. So I'm not doing this on z. I'm doing it on x, the amount of money consumers spend. So less than $90. So that needs to be 90. That's why it came out wrong the first time I rushed to hit the button. Oh my gosh! It's the same value! Look, same, same. Same, z, mean 0, standard deviation 1. Same, mean $74, standard deviation $17.3. Sorry, $17.30. Same stuff, different distribution. Yay! Okay, now let's look at another one. So, for B, what we want to do is we want to find the probability that they spend between $70 and $100. Okay. Let's do that using Minitab. So, although I could hit the edit last dialog box to do this, just so you see where this comes from again, I'm going to go to Graph, Probability Distribution Plot, View Probability, and it's going to remember where I was last, so it's still $74, still $17.30 is my standard deviation. But now, I don't want a left, I don't want a right, I want something in between. So, middle! Notice how the little pictures guide you to what this is. It's got shaded what area you want and stuff in between. We don't really use both tails that much. Alright, my lower value is $70. My upper value is $100. Let's go ahead and hit OK. When I do these at home, oh crap, that's what I'm doing right now. Usually I draw the picture first of what it should look like and then have Minitab show it for me. So since the mean is 74, it's like right here, so notice that corresponds with the peak, and 70 is just to the left of that, and 100's over here. And that makes sense based on the standard deviation. So it turns out this is almost half, or sorry, this is almost slightly bigger than half. Ooh, why is it not drawing? So 0.525. Does this feel fast? Because it should. Woohoo! All right. Cutoff value for the lowest 10% of consumer spending. So I want to find the value of X so that when I look at stuff below it, so all the values less than something gives me 10% or 0.10. So notice here I don't know the X value. I know, oh my gosh, I know the probability. So this is going to change it up. We're going to go backwards. This is the thing I was trying to avoid doing by hand because it's a pain in the butt. Let's use Minitab. All right. So we're going to go back to Graph. Probability distribution plot, view probability. I'm going to go back to shaded area, and here's the difference. I told Minitab the X value when I knew it, so it was somewhere between 70 and 80. Sorry, 70 and 100. Wow, I wrote those zeros terrible. Here, I don't know X values. I know probability. Oh, well, the stuff smaller than this is 10%. So we're going to go to probability this time. All right, so it's going to ask you, what probability do you know? Well, it's going to be 10%, so 0.10. Notice I'm using probabilities here, not percentages. You should probably just use the probabilities. And then when I think about this, it's the stuff smaller than a particular unknown value. So this is stuff to the left. So if you're picturing this in your head, you should be thinking, here's my distribution. I want the stuff in this area lower than this z value or x value. I don't know. That's supposed to be an x. And that's 10%. Ooh, that's like the worst drawing I've ever drawn. Yikes. I need to find another drawing program. That'll open Word documents. So left tail, stuff lower end. Okay, let's hit OK. Da 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 da. Aha! So stuff people that spend less than $51.83. That's the lower 10%. So $, yeah, and then $5, $51. Who pays my bills? And 83 cents. So this would be the cutoff. So notice what I'm circling here. Circling. Ugh. Whoever taught you that habit, by the way, is just lazy and didn't want to look through all your work to see if it was right or wrong. Those are the correct answers to these. Notice I don't need the graphs to do this, but I do need the graphs to tell what's happening. So what Minitab does is what any... Oops. Okay, that's so not the right one. Here's how you fix that problem. Go to the session window. The last one I opened is the right one. There we go. So notice I just clicked on that link and it popped up the correct one. Minitab arrange this as like you should. Along the axis is the x values, and then it does your area with the shaded in red, and then it puts the area value right above it. So stuff floating up here, that's going to be your area. Stuff down here, that's your value of interest. The 99th percentile for consumer spending. All right, so here the 99th percentile means I want to figure out which people fall to the value so that the area below is 99%, which we're going to call 0.99. So this is going to be a left again. So I'm just going to re-hit buttons. So as you look at this, when you see percentiles, they're always in terms of who you scored better than. So 99% of people scored below you. That makes you in the 99th percentile, in case you've ever taken a standardized test. So I'm going to hit the last edit dialog button since it was a left tail. So still the same setup. Left tail, only now the probability I'm interested in is 99. And again, this is fast because this should all be review. All right, so people that scored... spent $114. I should just type this and give up, but then I can't draw those lovely drawings. That's why we're doing this, in case you were wondering. And 20 cents. Hey, those be your lovely people who are in the 99th percentile. There's a lot of daily spending for those individuals. Let's do some IQR. So, IQR. There's a couple different ways I could set this up. So I'm going to draw a picture of this first to remind you of some stuff. So remember, the quartiles divide your data into quarters. So first step, we divide it in half. Oh look, that's the mean, yay! And then next you divide that into quarters. So again, I'm doing this by area, not location. So I want the same amount of area to show up here as here to give me quarters. So I'm going to say it's probably like right there-ish. So if you imagine coloring this, it'd be the same amount of crayon gets used. This one's not right. I'm just trying to make it look symmetric to that one. So this is probably my Q1. And this is probably my Q2. And this is my mean. I already know what this is. That was at $70. Good times. And now I've got this divided into quarters. So this is 0.25. This is 0.25. This is 0.25. This should have been further over. And this is 0.25. And this should have looked symmetric to that side, so this would look more accurate, but it doesn't. Anyway, we're just roughly trying to get an idea. So as you look at this, there's a couple different ways you could do this. You could be like, okay, so to find quartile 1, I'll do a left with 0.25, and that'll give me this guy. And I'll do a right with 0.25, and that'll give me this guy. But I'm lazy. I noticed that in both of my quartiles, I have about 50%. Or below the first quartile is 25%. And above the third quartile, that should be 3, not 2, is 25%. So I'm going to do this two different ways. So the first way probably is the one that would make the most sense. So I'm going to go to Stat, Basic Statistics, Graph, Probability Distribution Plot. I'm not fixing that. That was a 5-second screw up. Shaded area. And here's what I'm going to do. I'm going to do middle. So notice middle is the shaded part. That needs to be 50%. And how you do middle is it matches the picture. So notice there's little p1 on this side. So that's the probability to the left of the area that you're interested in. So I want the middle to be 50% because that's what the interquartile range is. It's the middle 50%. Or the length of the middle 50%, I should say. Ooh. So this little bit is 0.25. 0.25. And then if you look at the little p2, it's above the area you're interested in. So this part above the area of interest is 0.25. So that's also going to be a 0.25. And then we're going to hit OK. Alrighty. Move this up. So there's my quartiles. So notice by this, Q3 appears to be 85.67. I'm not done yet, by the way. And Q1 is 62.33. To get the IQR, you have to do Q3 minus Q1. So I need to subtract these two. So I got to do 85.67 minus 62.33. Wow, that came up so much worse the next time. My bad. My apologies. So 85, I'm calculating this right now. Minus 62. And that comes out 23.34. That looks horrendous. I should have typed it. Anyway, so what's the other way you could do this? Well, you notice that I could do instead the other way. Ha 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 ha. Edit last dialogue. So instead of doing 25% on each side to get me the middle 50, I can use both tails and say, how much is in both the tails? Well, 50%. So notice this is p over 2, p over 2. So when I take the probability given here and divide it in half of it goes here on the lower tail, half of it goes here on the upper tail. So if you look at my two tails, 25 and 25 makes 50. So I want 50% divided into half the tails. And when we hit OK, oh my gosh, hold on, reveal. Da, 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 da. It came out exactly the same. The upper one's 85.67. Da, da, da. The lower one's 62.33. Da, 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 da. Doesn't matter how you do this, it comes out the same. Sometimes both tails is actually faster, so fun facts. Good times. Great math. That's all I've got for you. Did you enjoy your math, baby? I hope so.